Hello, I'm David Hurd, and this is my Lab 3 black hole. To start, we're going to have to introduce a couple ideas. The first one being Newton's second law, the momentum principle, which states that a system's change in momentum is proportional to a net force on it. The second one is Newton's universal law of gravity, which goes as follows. We're also going to have to talk about force decomposition and the parallel and perpendicular component, which are shown here, both in equation and in code. The purpose of this lab is to use Newton's gravitational law and the momentum principle to calculate the net force and its components on a star orbiting a black hole, and to use this information to calculate the mass of the black hole and to find the velocity of a spaceship traveling around it. The preview is that these are the results of both experiments. Part 1 is finding the mass of the black hole. Where the system is a star, the surroundings are the black hole, and these are the initial conditions, which are also shown in the code here. In GlowScript, this is what it will look like. In the code here, we'll show you how vinit and vfinal are calculated, and how those are used to get the pinit and pfinal. Fnet and all of its components are equal to the change in momentum and its components. The change in momentum is equal to the change in momentum over the change in time. The parallel component is equal to the momentum parallel component. Perpendicular is just the total minus the parallel. And the result of all of this, using this equation in the code down here, is 1.13 times 10 to the 34 kilograms. Part 2 is called Don't Crash, where the system is the spaceship, the surroundings are the black hole and the planet, and the initial conditions are as follows. Up above in the code is how we calculate the speed and velocity of the planet. And the goal is to get it as close as possible, and this is the result that I had. In this code, you can see how we found the location and force of all of the three objects on each other, and used all that to get the ship's velocity and position updated. The result is that I got it 1 times 10 to the 8th meters away from the edge of the black hole by having it travel 3.606 10 to the 7th meters per second. Possible errors are program glitches, approximations, and there's always going to be a better solution to part 2. Now, what does it all mean? The rate of change versus net force. Both of these will be about the same value all the time, but they represent different things. The rate of change in momentum represents the change in the mass and velocity over a time, while the force represents an acceleration of a mass. Now, what if we wanted the ship to orbit in part 2 and have something like this picture here? Well, we'd have a velocity that is about 1.005 times 10 to the 7th meters per second, with components below. Thank you.